Hello everyone, this is Lady Emmanuel coming with you with I can write linear equation given the slope and the y-intercept of the standard form, a graph, a point and slope, and also 2 points. I just to let you know the forms that we will use to write it in, just to interchange, we will write it using slope intercept form. You guys probably recall that. Slope intercept form is good to write it when you have the slope and the y-intercept, okay? So if you're given the slope and the y-intercept, this is an excellent formula to just substitute that value for slope and the y-intercept in there, and it makes it much easier. Now, if you're given also, if you have the y-intercept and the slope, you could use what we call point slope formula, okay, which it is y minus y sub 2 equals y sub 1. And I usually do that. I'll put y sub 1. I won't put the 1, but I'll put the 2 equals the slope, open parentheses, x of 1 minus x of 2. Okay. This right here is your lovely point slope formula. So you can see that if you have a slope, and in this case, you just need 1 point, a slope and a point, okay? In the point, y-intercept is a point because you're given the x, it will be 0. The y-intercept is basically 0, comma b, okay? B being the y value on the y-axis. So if you're given this, you could also substitute it in this formula, and it makes it much easier just as well. So these two, slope, intercept, point, slope formula, will substitute in. If you give me 2 points, I will use this because I found the slope, or I can use that. It doesn't matter which one you use. You need to be familiar with it. So I will go back and forth. Now the standard form, now when I use the standard form, actually, I would just convert the slope intercept form to standard form, which would be a of x plus b of y, b times y. So ax plus by equals c. Where these are real numbers, okay? Real numbers, it doesn't matter if they're decimals. They could be decimal, I guess. But usually you don't see it like that per se, unless you're dealing with real world situation. And if you're dealing with a real world situation, you're going to see the real thing. Okay. So with that being said, let me turn back over and give you some nice little notes of how to write a linear equation given the slope and y-intercept. So they gave me the slope and y-intercept. I'm going to use the slope intercept form. The slope intercept form, like I previously said, is y equals mx plus b. Okay, b being the y-intercept. So here they told me the slope was 1/3. So since this slope is 1/3, which is my m, and this is -5, which is my b, all I have to do is substitute those values in for the corresponding variables that I have assigned. So I have y equals 1/3 x minus 5. Bam, I'm done. I have written this in linear equation, okay? You probably say, what if I wanted to write it in standard form? I'm glad you asked. If you want to write it in standard form, I may have to put it, I'm going to say look on back. I'm writing this for myself too, for it to be in standard form. Okay, so if you go over to the back, I will show you this. So here we go. Let me do this like that. I'm going to say y equals 1/3 x minus 5. And I want to write this equation sorry, write in standard form. So I want to write this equation in standard form. I need to slow down because when I talk fast, my pronunciation really is not that good. So I want to write this in standard form, meaning ax plus by equals c. So what I'm going to do, I want my x and my y on the same side of the equal sign. Since this here is a positive 1/3 x, then I'm going to subtract 1/3 x from both sides of the equal sign because I am basically manipulating an equation and you do the inverse operation. This comes out because they're added to inverse, leaves me with negative 1/3 x plus y equals negative 5 because that subtraction is with that 5, meaning it's a negative 5. Here, it still isn't in the format. I need it to be ax plus by equals c. I need to get rid of that fraction there. You don't see standard form written with a fraction. That's slope-intercept form. So therefore, what I'm going to have to do is multiply every term in this equation by negative 3 because whatever my denominator is, that's what I want to get rid of. Okay? So what I'm going to do is say, okay, multiply that by negative 3. So I have negative 3 times negative 1/3 x plus negative 3 times y equals negative 3 times negative 5. Okay? I distribute that negative 3 throughout the entire equation. Once I do that, I have negative 3 times negative 1/3. Negative times negative is a positive. The 3's cancel out, leaving me with 1x. Negative 3 times y is negative 3y equals a positive 15. Okay? So I went from slope-intercept form to standard form. And you need to be able to go back and forward, and you need that because if you see it in this format, you know that you can write it in slope-intercept format just as well. And I get the same information. The y-intercept, that means that I substitute 0 in for x, meaning that I'm left with 3y equals 15. I want the y by itself, divide both sides, and I will have it. And what did I do? Yeah, divide both sides by negative 3, and I'll have my lovely negative 5 for my y-intercept. So just make sure you be able to go back and forth. It takes time, okay? It'll take some time. So now standard form, back to standard form. Now, since they gave it to me in standard form, I'm going to write this in slope-intercept form. Okay? You probably said, you like that. And when I say write it in slope-intercept form, that means that I'm isolating the y. So I want to get y by itself. That's what I'm trying to do, is get this y by itself. So before I can get the y by itself, that means that I have to get rid of the 4x. I need it to be gone. Therefore, I'm going to subtract 4x from both sides of the equation. This cancel out. That goes to 0 because it's at its inverse. Bring down my negative 2y equals negative 4x. Negative 4x plus 14. I'm smiling because, guys, you know I could have written this right over here. So I'm going to take this over here. So I have negative 2y equals negative 4x plus 14. Okay. So is the y by itself? Absolutely not. What is the coefficient of the y? Basically, what is the value in front of the y? That is a negative 2, meaning I need to get rid of it by dividing each terms by that coefficient negative 2. Negative 2 divided by negative 2 is a positive 1. Therefore, it cancels out, leaving me with 1y. Negative 4 divided by negative 2 is a positive 2, giving me 2x. 14 divided by negative 2 is a positive. 14 divided by negative 2, that leaves me with negative 7. We don't write plus negative 7. We just write negative 7, which is a subtraction sign. So now I have it in slope-intercept form. So I know what my slope is. I know my y-intercept. Bam. Okay, just practicing going back and forward. And you probably say, well, this is already a linear equation. Well, guys, on the LC, you have it in standard form. But then, if you want to graph it, perhaps you can graph it faster with slope-intercept form. And it's other ways, so many different ways. We need you to be familiar with all of it. Okay, they may want to know which equation is equivalent to 4x minus 2y equals 14. And the choices all could be in slope-intercept form. Okay, or it could be a graph. You don't have to just be equations. So you want to be familiar with all of it. So just like this graph, they may ask you which, they may give you choices. It could be multi-steps, you know. It could be like, okay, what graph goes with this equation? Which does this match? Which does not match? 4x minus 2y equals 14. And they can give you a table. They can give you an equation. They can give you a graph. They can give you mapping. So I want you to be familiar with all of it. Okay. This graph, it told me to write this, write an equation. Now I'm gonna find some points that just integer. I don't want decimals because it's the infinite amount of points. So here, they sort of got to highlight it for me. Okay.